Hello students, welcome to physics classes. In this lecture I am going to explain you the principle of superposition of waves. You just first of all write the definition in your notebook. When two pulses of equal and opposite shapes moves towards each other and overlaps. I have two pulses which are equal in shape, which is these two pulses having equal shapes but opposite faces. Okay, this pulse is having upward face and this pulse is having downward face. Okay, these pulses are having opposite shapes. Shape is nothing but face. Moves towards each other. That means this pulse is moving towards this pulse and this pulse is moving towards this pulse and overlaps each other. After some time they overlaps each other. Then the resultant displacement is the algebraic sum of the displacement due to each pulse. For this pulse the displacement is y1 of x comma t, and for this pulse the displacement is y2 of x comma t. And after overlapping, the resultant displacement will be y of x comma t, and it will be equal to algebraic sum of the displacements due to each pulse. We are having two pulses, that is y1 of x comma t and y2 of x comma t. Okay, the resultant displacement will be the algebraic sum of these two pulses, and after overlapping each other, here the pulses disappear. At this position, the pulses disappear. Why it's happening? Why? Because the amplitude for each wave will be equal to 0 after overlapping each other. That means there is no displacement of the particles. There is no displacement of particles. If there is no amplitude, there is no displacement of the particle. Therefore, at this point, there is no transfer of energy. Right? So, whenever there is no displacement of the particles, then there will be no waveform. The resultant waveform will be equal to 0 as the displacement of the particles is equal to 0. Okay. So, if this is a case whenever the waveform contains two equal and opposite pulses and which are moving towards each other. Okay, if the waveform contains two pulses of equal and same shape, okay, that means the phases of these two pulses are equal. There is no phase difference between these two pulses. Here there is a phase difference between these two pulses and it will be equal to 180 degrees. Okay, here there is no phase difference. The phase difference is equal to 0. Okay, and for these pulses, that means these are crests, these are throws. Two equal throws or two equal crests. For equal throws and equal crests, the phase difference will be equal to 0. Whenever they overlap each other, then there will be a resultant displacement. Which will be not equal to 0. Here in this case, whenever the waveform contains two equal and opposite pulses, overlaps each other, the displacement will be equal to 0. Okay, and if I have more than two waves, for more than two waves, the resultant displacement will be the algebraic sum of the displacements of each pulse. Okay, for example, I have a wave whose displacement is y of x comma t, and it is a function of x minus vt. That means this waveform depends on the position, time and speed. Okay, and I have one more wave which is a function of f2 of x minus vt. See, these both waves contains equal position, equal velocity and equal time. There is no difference between the position of the waves, there is no difference between the speed of the waves, there is no difference between the time when they overlap. Okay, and I have n number of waveforms. If I have n number of waveforms, then the resultant displacement of these waveforms after overlapping will be equal to the sum of the waveforms, the algebraic sum of these waveforms. Okay, the resultant displacement will be equal to y1 of x comma t plus y2 of x comma t plus and so on plus yn of x comma t. Okay, then this can be written as y f1 of x comma t x minus vt plus f2 of x minus vt plus and so on plus fn of x minus vt. Okay, and I will rewrite this equation as summation I equals to 1 to n fi of x minus vt. Okay, this is the resultant displacement after superimposing of n waves, Okay, and coming to the interference of waves. Our next topic is interference of waves. Interference of waves is nothing but it's a phenomena of principle of superposition of waves. Okay, in that whenever two waves, coming to the interference of waves, when two waves superimpose each other, then the resultant amplitude might be greater or lower or also equals to 0. Okay, coming to the interference of waves, whenever two waves superimpose each other, then the resultant wave have the amplitude might be greater, lower or equals to 0. Then the resultant wave will have the amplitude greater, lower or equals to 0. Okay, for example, I have two waves and whose displacement will be equals to a sine of kx minus omega t, and this is the displacement equation for wave 1, and for wave 2 the displacement is equal to a sine of kx minus omega t plus phi. Why I have taken here phi and why I didn't take any phi here? Why? Because here this pi is equal to 0. The initial phase angle is equal to 0. and the initial phase angle is phi here. Okay, the phase difference between two waves is equal to phi. That means these two waves, whatever superimposing each other, might have two different phases or might have two equal phases. Okay, here we are going to discuss about these two cases after deriving the resultant displacement equation. Okay, now coming to the resultant displacement equation, this will be equal to the algebraic sum of these two waves, that is a sin of kx minus omega t plus a sin of kx minus omega t plus pi. This pi is the phase difference between these two waves. And you just observe carefully, this equation is in the form of sin a plus sin b. Sin a plus sin b. Sin a plus sin b is equal to 2 sin of a plus b by 2 into cos of a minus b by 2. Right? This is the equation from trigonometry. And you just compare this equation and rewrite this equation as, here I am taking small a, okay, small a. This is the initial amplitude of each waves, and this resultant displacement will be equal to, I am taking a common, okay, this is sin a plus sin b. I am taking a common in this equation, okay, I am taking a common. Then this will be equal to a sin of 2 sin, here I have 2a sin of a plus b by 2. Here kx minus omega 2 is a, kx minus omega t plus phi is b. Okay, kx minus omega t plus kx minus omega t plus pi by 2 into cos of a minus b. This is kx minus omega t minus kx, minus into minus will be plus omega t, minus into plus will be minus pi by 2. Okay, now this resultant displacement will be equal to 2a sin of kx plus kx will be 2kx minus 2 omega t plus pi by 2 into cos of minus kx plus kx minus omega t cancels, will left with minus pi by 2, and this will be equal to 2a times of sin 2 get cancels, will left with kx minus omega t plus pi by 2 into cos of, what is cos of minus theta? Cos of minus theta will be cos theta. Therefore, here cos of minus pi by 2 will be cos of pi by 2. Okay, this will be the resultant displacement whenever two waves interfere each other. Interference is nothing but combination of two or more pulses. Okay, combination of two or more waves. Okay, I told that whenever two waves superimpose each other, then the resultant wave will have the amplitude greater, lower or equal to 0. We have to prove this. Therefore, here in this equation we have the sine function and also the cos function. But I need only the sine function. For this purpose I am considering this 2a 2a cos pi by 2 as the amplitude. Okay, this is the amplitude of this resultant displacement wave equation, and this amplitude is phase dependent. Okay, therefore I have taken here a of phi. Now substituting in this equation, this 2a cos pi by 2 is a of phi into sine of kx minus omega t plus pi by 2. This is the resultant displacement wave equation. Okay, and here I am considering two cases. Whenever the phase difference is equal to 0 and whenever the phase difference is equal to 180 degrees. Okay, for case 1 and for case 2, whenever the phase difference is equal to 0 and whenever the phase difference is equal to pi, nothing but 180 degrees. Okay, and this is equation number 1, this is equation number 2. From equation 1, this y of x comma t will be equal to 2a into cos of 0 by 2. What is cos 0? Cos 0 will be equal to 1 into sine of kx minus omega t plus 0 by 2. This will be equal to, sine 0 will be equal to 0 and cos 0 will be equal to 1, right? Therefore, we left with 2a sine kx minus omega t. Kx minus omega t. This is a displacement equation. This is the displacement wave equation whenever there is no phase difference between two pulses. Okay, and if there is a phase difference of 180 degrees, then the displacement, resultant displacement equation will be equal to 0. That is, there is no displacement of the particles. Okay, whenever two pulses overlaps each other, this resultant displacement of the particles, will be equal to 0. That means there is no displacement of the particles at this position. As the displacement of the particles will be equal to 0, therefore the amplitude will be equal to 0. Right? Here in this case the amplitude is twice the initial amplitude. Right? The amplitude is twice the initial amplitude, and in this case the amplitude will be equal to 0. You just substitute this pi equals 180 degrees in this equation. Okay, cos 180 by 2 will be 90. Cos 90 is equal to 0 and 0 into sin theta will be equal to 0. Therefore, this resultant displacement will be equal to 0. Okay, here the amplitude is equal to 0 and here the amplitude is the twice of initial amplitude. And this waveform is known as constructive waveform. Constructive waveform. And this waveform is known as destructive waveform. Destructive waveform. Why? Because after adding the two waves, after adding the two waves, that is y1 and y2 waves, the resultant displacement is equal to 0. Okay, therefore this waveform is said to be destructive waveform, and also in this case the amplitude is equal to 0. For constructive waveform, the amplitude will be twice of the initial amplitude. Okay, therefore is said to be constructive waveform. And I want to explain you one more point, that is the waves here, whatever I considered, are known as harmonic waves. Just take this screenshot. Okay, you just pause the video and take this screenshot. Harmonic waves, whatever I considered here, are harmonic waves. In harmonic waves, the wavelength of both the waves, are equal, and angular frequency, that is omega, is also equal, and wave number is also equal. Therefore, the amplitude of the waves is also equal, and the wave speed of both the waves are also equal. Harmonic waves are the waves whose wavelength, angular frequency, angular wave number, this is wave number, amplitude and the speed of the waves are equal. Okay, and here I will end our lecture. In our next lecture, I am going to discuss you about the topic reflection of the waves. Okay, and please, whoever didn't subscribe to my channel, please subscribe to my channel and share with your friends, and also click on the like button for more videos. Okay, bye.